Why methane emissions do not undermine peatland rewetting for climate change mitigation. Do intact peatlands emit methane? Yes. Plants growing in intact peatlands or mires are adapted to the oxygen-poor conditions of the permanently wet peatland soil. Like other plants to grow, they take up the greenhouse gas carbon dioxide from the atmosphere through photosynthesis. After plants die, part of the dead plant material is conserved under waterlogged conditions. In presence of oxygen, organic matter is rapidly digested by microbes. Under waterlogged conditions, however, the available oxygen is quickly used up and digestion slows down. Instead of oxygen, other microbes then use nitrate, manganese, iron and sulfate to digest the organic material. When these get depleted, microbes that can use carbon dioxide or the organic matter itself as a substitute for oxygen take over. This final step in microbial decomposition produces methane. Methane is a strong greenhouse gas, stronger than carbon dioxide. However, in the absence of oxygen, decomposition remains incomplete and dead organic matter accumulates in the form of peat, thereby permanently removing carbon dioxide from the atmosphere. Although they emit methane, growing mires worldwide are an efficient sink for carbon dioxide and have cooled the global temperature in the last 10,000 years by 0.6 degrees Celsius. Can we control methane emissions in re-wetted peatlands? Like a mire, a re-wetted peatland will emit methane. Depending on site characteristics and re-wetting practices, these emissions can vary, and in rare occasions be very high during the first years after re-wetting. If, for example, during re-wetting, easily degradable above-ground biomass or nutrient-rich topsoil layers with living roots are present, or if long-term flooding occurs, especially during the growing season. We can, however, minimize methane emissions by optimizing re-wetting measures by removing above-ground biomass before re-wetting, removing 5 to 10 centimeters of topsoil with living roots after evaluating potential methane emissions versus the effects of carbon stock removal, avoiding long-term flooding during the growing season, implementing controlled and slow gradual re-wetting, and fostering the growth of peatland-specific plants. Is it better to avoid complete re-wetting to prevent methane emissions? No. For the climate, it is always better to re-wet all drained peatland sites. The greenhouse gases carbon dioxide, methane and nitrous oxide are climate active in the atmosphere. They act like window glass in a greenhouse, letting sun radiation in, but trapping the heat inside the greenhouse. The gases differ in their capacity to heat up our greenhouse, planet Earth. Scientists say the gases have different radiative forcings. Methane has a stronger radiative forcing than carbon dioxide, but it also remains in the atmosphere for a much shorter time. So how do we compare the effect of the different gases? The Science-Based Intergovernmental Panel on Climate Change, IPCC, proposed to look at radiative forcings over a 100-year period. This metric is called global warming potential. The climate effect of different gases is compared with that of carbon dioxide and then expressed in CO2 equivalents. Methane has a global warming potential of 27 CO2 equivalents. Nitrous oxide of 273 CO2 equivalents. Nitrous oxide is emitted in small quantities from drained peatlands only and behaves much like carbon dioxide. If a peatland is re-wetted, nitrous oxide emissions stop. For simplicity, in the following we will look at carbon dioxide and methane only. Global warming potential is a single number metric that does not adequately address temporal aspects of radiative forcing when we compare drained and wet peatlands. For decision-making in peatland re-wetting for the future generations, we need to focus on the mid to long-term behaviour of greenhouse gases in the atmosphere. So let's have a closer look at the development of radiative forcings under different scenarios. Carbon dioxide emissions from peat degradation in drained peatlands under conventional agriculture on average amount to 30 tonnes of CO2 equivalents per hectare per year for grassland and 40 tonnes per hectare per year for cropland. Drained peatlands will continue to add 30 to 40 tonnes of CO2 equivalents per hectare to the atmosphere each year. Carbon dioxide can stay in the atmosphere for thousands and thousands of years. As long as peatlands remain drained, they will emit carbon dioxide to the atmosphere. In a business-as-usual scenario, the same amount of carbon dioxide would be emitted each year, resulting in a steady increase of carbon dioxide in the atmosphere. In a scenario in which even more peatlands are drained, this increase would be even larger. Yet, even when half of all currently drained peatlands would be re-wetted, still a lot of additional carbon dioxide would end up in the atmosphere each year. The only way to stop carbon dioxide emissions from drained peatlands is to re-wet them all. Re-wetting effectively stops emission of carbon dioxide and can even result in a new carbon dioxide sink. The methane produced after re-wetting is emitted in much smaller quantities per hectare per year. A re-wetted site in the temperate climate zone typically emits 250 kilograms methane per hectare per year. Moreover, methane stays in the atmosphere for only 12 years on average before it decays to carbon dioxide and water. Because of its short lifetime, as much methane will be removed from the atmosphere as is added. A dynamic equilibrium is established in which the total amount of methane remains stable. As at first instance the methane forms from recently grown plant matter, the carbon dioxide from the later methane decomposition in the atmosphere feeds back into the short-term carbon cycle of the site, not adding to global warming. Given a stable high water table, typical Maya vegetation will establish, creating a new carbon sink. Under the right conditions, new peat will be formed, making the site climate cooling after approximately 100 years. As long as peatlands remain drained, they release carbon dioxide into the atmosphere. Postponing re-wetting therefore means allowing more long-lived carbon dioxide to enter the atmosphere, shifting a potential cooling effect further into the future. All peatlands must be wet, and we must act now.